Hi everyone and welcome back. So we're going to be talking about geometric sequences today. But now before we do that, I actually just want to brush up on what you remember from arithmetic sequences. We learned those way back in end of first quarter, beginning of second quarter. Does anyone remember what an arithmetic sequence is? Before we get into what geometric is, we should probably remember what arithmetic. Some of you like to say arithmetic sequences. Okay? So the arithmetic sequence, now remember, I told you do not need to memorize the formula. Okay? The explicit formula for an arithmetic sequence. This comes straight from the reference tables for the Regents exam. Okay? So you don't have to memorize this. It's a sub n equals a sub 1 plus n minus 1 times d. So if you remember, if I said find me the fifth term, given that the first term is 2 and the common difference is negative 3. Okay, so the fifth term, that means when n is equal to 5, so the fifth term means n equals 5. Again, this is all from the arithmetic sequence. This is a little bit of a throwback from way earlier in the year. If I said given the first term is 2, so that means I know a sub 1 is 2, and the common difference is negative 3, that means d is negative 3. So we would just plug in. And I'll write that here below in black. So we'll have a sub 5 is equal to, we're finding the fifth term, is equal to 2 plus, plug in for n, which is 5 minus 1, times that common difference of negative 3. And I'm just going to put that straight in the calculator. And you end up getting negative 10. So this is an example of an arithmetic sequence. Arithmetic sequences, they must have a common difference. So remember, that common difference is crucial. That means we're either adding or subtracting. Well, if arithmetic sequences deal with addition and subtraction, what do you think geometric sequences are going to deal with? What other operations have we not talked about yet? So again, arithmetic talks about that common difference of addition and subtraction. What do you think geometric is going to talk about? Very good. Geometric is going to be talking about multiplication or division. All right. So now let's take a look at this first warm-up. And there's a reason why I went through this entire little explanation on the arithmetic sequences. Again, you have this formula that you do not need to memorize. This is given to you on the reference tables for the Regents exam. Okay. That is used for an arithmetic sequence when you have addition or subtraction of a common difference. So common difference is representative of our variable d. Remember, n represents the nth term, whichever term we're trying to find. And then a sub 1 represents the first term. All right, so keep that all in mind. So let's take a look at the first warm-up example. We have given the sequence of numbers. We've got 5, 8, 11, 14. Okay, the question says, explain why the sequence is arithmetic. Determine the common difference. So again, you got to remember what arithmetic means. Arithmetic means it's either being added or subtracted by a constant amount. So now some of you have actually mentioned this before in class. Arithmetic sequences do represent linear functions. Okay, if it's talking about an average rate of change, whether it's being added or subtracted by a constant amount, that represents something that's arithmetic, which is also a linear function. So we'll include that. Arithmetic sequences represent linear functions. Okay. So now, given that sequence of numbers, we have 5, 8, 11, and 14. What do you notice all of these numbers are going up by? They're all going up by 3. All of them are being added by 3. So that's your common difference. So why is the sequence arithmetic? Because there is a common difference of 3. So let's write that. All right, we already just said this. The common difference here is 3. Everything is going up by 3. Okay, so before we go to this think about question, I'm going to skip over this and we're going to return back to it. So I want us to actually look down towards the bottom of the page and we're going to look at the following sequence of numbers. So hopefully you pick up something a little bit different. So again, just very quickly, in this example here, we just talked about the arithmetic sequence again, given our little warm-up before beginning geometric sequences. So arithmetic is being added and subtracted. Geometric, we're going to be talking about multiplication and division. So let's take a look. You have given the following sequence of numbers, 4, 8, and 16. I want you to answer all of the questions. So let's see, is this sequence arithmetic? So is this being added and subtracted by a constant amount? So let's see, we're going from 4 to 8, and then 8 to 16. Well, if I'm thinking this is arithmetic, to go from 4 to 8, we had to add by 4. So let's see if that's the case. From 4 to 8, we add by 4. To get from 8 to 16, well, here you're going to have to now add by 8. So already I can tell this is not arithmetic because you're not adding by the same amount each time. There's no common difference. So let's write that. We're not adding by the same constant each time to get to the next term. Okay, so no, because you cannot add by the same amount each time to get to the next term, so there's no common difference, so it is not arithmetic. Okay, not arithmetic. All right, so what do you think the next two terms would be? So clearly we're not adding by the same amount here. So we talked about the other options. Instead of addition and subtraction would be now to look at multiplication or division. So let's see. Well, to get from 4 to 8, we had to multiply by 2. And in order for us to get from 8 to 16, well, again, we're multiplying by 2. So if I'm multiplying by 2 for all of these terms, what do you think the next two terms here would be? I have 4, 8, 16. 16 times 2 is 32, so that would be 32 here. And then 32 times 2 again is going to be 64. So those would be my next two terms. Okay? And now the question says, how do I get from one term to the next? Well, we just multiplied by 2. Multiplied by 2 from the previous term. Okay? Multiplied by 2 from the previous term. This sequence is an example of a geometric sequence, all right? So remember, geometric, we're looking at multiplication and division. Arithmetic is addition and subtraction. So to fill in the blanks here, any sequence where you multiply the previous term by a fixed amount, so if I'm multiplying by the previous term, okay, by a fixed amount, to get to the next term is called a geometric sequence. All right, so we're going to take a look at a few examples here. Okay, so we just did an example like this. So we have a geometric sequence. So we have a sequence is called geometric. So a sequence is called geometric if there is a real number r such that each term in the sequence is multiplied by r. So this r variable here is going to be really important for us to get to the next term. So we just did a sequence just like this above, right? It's the exact same numbers. We said to get from 4 to 8 and to get from 8 to 16, we multiplied by 2. So that's my r value. My r value is 2. We call the r value the common ratio. All right, so again, if I'm comparing the arithmetic sequence to the geometric, for the arithmetic, we used common difference, which we use the variable d. Now, for geometric, we are using the variable r for the common ratio. And how do we get r? Well, this is actually pretty important. We take any term in the sequence, and divide it by the previous term. So take any term in the sequence and divide it by the previous term. All right, so let's take a look. And again, this is actually going to be extremely, extremely important of how to find r. Take any term, divide it by the previous term. All right, so let's take a look. We have 2 to 6, 6 to 18. So let's use this piece here that we just talked about. Take any term and divide it by the previous term. Well, I'll take any one of these terms. So let's take a look at, we'll say 18. And its previous term is 6. So I'm going to take 18 and divide it by that previous term of 6. I'll divide them together and get my r value to be 3. That's another way of looking at it. So instead of saying, oh, I'm multiplying by 3 every time, because we're going to get some fractions here, which is going to actually get a little bit more complicated, I encourage you to use this formula here. Take any term, divide it by the previous. So I'm taking my 18 and I'm dividing it by 6. I could have also done this with 6 and 2. I'll take 6 and divide it by the previous term of 2, and I'll still get 3. So my r value here is 3. That's the common ratio for a geometric sequence. So let's fill in what the next few terms are, and I think you would be able to do this. Why don't you pause the video here and give that a try. All right, good. So again, because we're multiplying everything by 3, everything's getting multiplied by 3. 18 times 3 is 54. And 54 times 3 is 162. So those would be the next two terms in our geometric sequence. All right, so very quickly, I want to take a look at question number 5, and I actually want to see if you can start this on your own. Remembering this formula right here. To get that r value, that common ratio, we take any term and divide it by the previous term. So why don't you give question 5 a try using this information. So I would pause the video here and give this question a try now on your own. Okay, so we have take any term. So I'll take the 100, sure. I'm going to divide it by my previous term. So here's 100. My previous term is negative 20, so I'm going to divide it by negative 20. My r value is negative 5. So that's it. My common ratio is negative 5. We know we're looking at a geometric sequence. I could have also used negative 20 and 4. I could have said r is equal to negative 20 over 4, which is still negative 5. See how it doesn't matter? You have to just look at any term and then divide it by the previous. Okay? So that's coming from here. All right, so the next few terms would be if we're multiplying everything by negative 5. So we're multiplying by negative 5 here and here. We'll get 100 times negative 5 is negative 500. And then negative 500 times negative 5 is 2,500. All right? So now I want to take a look at questions 6 and 7. Now, here is where it's going to be really important that you guys are following my directions here and you're using this formula. How to get the r value? We take any term and divide it by the previous term. Really important for questions 6 and 7 that you're definitely following my lead here. So, I'm going to take any term in this sequence. So let's start with 8, any term. And I'm going to divide it by the previous term. So if 8's the term I'm choosing, previous to 8 is 16. So I have 8 over 16. If you put that in your calculator, guys, 8 over 16 is a half. Now my r value is a fraction. Really important here. So I am multiplying every value here by a half to get from one to the next. Okay, really important. Make sure you're using this formula. Take any term, divide it by the previous term. So 4 times 1/2, that's 2. And 2 times 1/2 is 1. Okay, very similarly for the question number 7, I want you guys to try this on your own without me. But again, follow this formula. Take any term and divide it by the previous term. So I would pause the video here and give that a try. All right, so if we picked any term, so if I pick 20, for instance, pick any term and divide it by its previous term, so 20 divided by 100, we end up getting, if you put that in the calculator, write it as a fraction, we end up getting 1/5. So my R value is 1/5. So that's the common ratio. So that means every number here is getting multiplied by 1/5. So 20 times 1/5 is what? 20 times 1/5 is 4. And then again, we're multiplying by 1/5. 4 times 1/5 is 4/5. So there you go. There is our geometric sequence, okay? So let's take a look to see if we can come up with a more standard equation here. So for question 8, we have, given the following sequence, find its missing terms. So the question is already prompting us with what's the common ratio. So we already know we're looking at something geometric where we want to take any term. So to get that common ratio value, we're going to take any term and divide it by the previous term. All right, so remember that. Take any term divided by the previous term. So let's take whichever term you guys want. What do you want to pick? Sure, we can go with 24. And the previous term to 24 is 12. So I have 24, and I'm dividing that by 12. Well, 24 divided by 12 is 2, so my common ratio is 2, meaning we are multiplying every term here by 2. Every term is getting multiplied by 2. All right, so to find those next few terms, we have 24 times 2 is 48, and 48 times 2 is 96. All right, so how did we get to the next term in the sequence? What did we end up doing? All right, good. We multiplied. So we multiplied each term by 2. We multiplied each term by 2. That's our common ratio. Really important vocabulary here, guys. All right, so that's our common ratio. We multiplied everything by 2. Now, if you remember this notation from, like I said, way back when, if I have a sub 1, a sub 2, a sub 3, a sub 4, etc., remember, a sub 1 is the first term. So what's my first term in this sequence? The first term here is 3. So I'm going to write 3. What's my second term? Good, my second term is 6. So I'm going to write 6. My third term is 12. So I'm going to write 12 next. My fourth term is 24. So I'm going to write 24. Fifth term is 48. All right. And we're just continuing down the line. And my sixth term is 96. So we have our sixth term is 96. All right, so I tried to color code that for you guys. All right, so it's really important that we know our a sub 1, first term, a sub 6 would be our sixth term. All right. So how did we get to the next term in each sequence? Well, we multiplied everything by 2. So we need to come up with a generic formula to finding the nth term. Now, both of these formulas here are not going to be given to you on the Regents exam. You do need to know them. Okay? So while I said earlier that arithmetic sequence from way up here, all right, this arithmetic sequence right here, I told you didn't need to memorize. They give that to you on the Regents exam. Well, down here, you do have to memorize these formulas that we're about to list. All right, so you need to memorize. All right? So, before we can write the sequence, we need to actually figure out what the formula is. So, let's take a look at what I have written here. So, we know the first term here was 3. This is looking at this sequence from up here. We know the first term was 3. All right, so I have a sub 1 is 3. A sub 2, well, we're just taking that first term and multiplying it by 2. So we have 3 times 2 to the first. Okay, so 3 times 2, this is the same thing as writing 6. For the third term, that a sub 3, well, again, we're taking the first term and we're multiplying it by 2 twice. Because 3 times 2 is 6. 6 times 2 is 12. So that's 3 times 2 squared. Again, hopefully we're picking up on a pattern here. Now to get to the fourth term, again, you're taking that first term and we're multiplying by 2 now 3 times. Note that difference. To get to the fourth term, we multiplied by 2 3 times. When we multiplied to get a sub 3, we multiplied by 2 2 times. Okay, and just to quickly write in here, a sub 4 we know was 24. So if I want to get to the fifth term, well, it's going to be the same thing. We need to multiply by the initial amount of 3 times 2 once, twice, 3, 4 times. It's always going to be 1 less than that n value that we're looking for. So if I'm looking for a sub 5, I'm multiplying by 2 4 times. If I'm looking for a sub 6, I'm multiplying by 2 5 times. All right? So let's write that out. This is the same thing as writing 3 times 2 to the fourth, which is the same thing as 48. If I'm writing a sub 6, again, we're multiplying by the initial amount, and we're multiplying by 2 now 5 times. So I have 5 copies of 2, so that's 3 times 2 to the fifth, which is 96. If I wanted a sub 30, again, we're taking, let's see, if I want a sub 30, still write down that initial term, so the initial amount, which is 3, times, we would be writing this out, times 2 to the 29th. It's always 1 less than the n value. So if we want to write down a generic formula, well, let's see. Let's observe what we've done so far here. Let's look at everything we've done so far here. Notice how everything is starting with a 3. And in our case here, remember, this 3, I'll highlight that here in black. This 3 represents the first value. That's our a sub 1. So I have a sub n will equal a sub 1 times. Well, we keep multiplying, if you guys notice in here. Everything keeps getting multiplied by 2 a bunch of times, right? What does 2 represent? What did we say 2 was? 2 was our common ratio. 2 we represented as r. So we're multiplying it by the common ratio, and we're raising it to, well, how many times do we multiply by 2? We multiplied it by 1 less than the n value. So if we take a look here, see how here n is 30? Well, to get 29, we're doing n minus 1. So this is a sub 1 times r to the n minus 1. You need to know this formula for the explicit formula for a geometric sequence. Okay? You need to have this memorized. All right? And I'll highlight that over here in yellow. You need to have this memorized, the explicit formula for a geometric sequence. The recursive formula for a geometric sequence is really all this is saying here, guys. Take the previous term and multiply it by that common ratio. So we've been doing that this whole time. That's the recursive formula. Really, the one that you do need to truly have memorized is what I have highlighted here in yellow. Okay? This one right here will fall into place. This one is kind of nice. Remember, this is just saying take the previous term, multiply it by the common ratio, which is what we've been doing. All right, so let's keep going. Let's just take a look at some more practice problems. So why don't we start off with the top here? So we're going to find the geometric sequence. And remember, I wrote this up here for you at the top. A sub n is equal to a sub 1 times r to the n minus 1, the formula that you need to have memorized. So let's see. To find this geometric sequence, notice how it says find a sub 8. What does that mean n equals if I want a sub 8? Good. N equals 8. Now, remember, we need to fill in all the blanks here. We need to know what a sub 1 is, we need to know what n is, and we need to know what r is. All of which we are plugging in to this formula. So, first, find that common ratio. So the common ratio, well, let's see. To find r, we take any term and divide it by the previous term. Take any term, divide it by the previous term. So pick a term. Sure, I think I heard that in the back. Someone said 50. Awesome. So we're going to take 50, and we're going to divide it by the previous term to 50, which is 10. 50 divided by 10 is 5. So your common ratio is 5. So now we have r, so we can check that off the list. Found r. We want to write the explicit rule for the nth term of the sequence. All right, so before we can do that, we need to first identify what's a sub 1. So a sub 1, I'm going to highlight that in red. A sub 1, that's our first term, so that's 2. And n, we already acknowledged here, is going to be 8. We want the 8th term. So let's write it out. Let's fill it in. Okay. We want a sub 8 is equal to, I'm just using this formula here, take the first term, which is 2, multiply it by the common ratio r, which is 5, and we are raising that to the n minus 1, where n is 8, so I have 8 minus 1. All right, and guys, just put this straight into the calculator. Remember, to get something raised to an exponent, you use that caret button, which can be found between clear and the division symbol on the calculator. All right, so when you plug that into the calculator, we end up getting 156,250. All right, so let's just keep going through some practice here. All right, so let's take a look at question 10. And I encourage you to probably pause the video here and try question 10 on your own. Remember to identify what a sub 1 is, what n is, and what r is, and we're plugging into this formula. All right, so pause the video here and see if you can figure out what those values are. Okay, so we should have had a sub 1 to be 4. That's our first term. We're finding a sub 13, so I'm looking at my n value to be 13. And r, to find r, remember this formula, we take any term and divide it by the previous term. So if I pick any term, I'll pick, 36, sure. And its previous term is 12. So if I take 36 and divide it by its previous term of 12, well, 36 divided by 12 is 3, so I have r equals 3. So I have all the information that I need here to plug into my formula right here. We want a sub 13, that's what the question says to find. All right, let me uncover that since I have it hiding behind this pen. So we want a sub 13. So a sub 13 will equal, we take the first term, which is my a sub 1 of 4, times the common ratio of 3, and we're raising it to the 13 minus 1. And guys, again, just plug that in the calculator and let me know what you get. So we should end up getting, so a sub 13 equals 2,125,764. So that's a sub 13. Again, all of these are geometric sequences because everything is getting multiplied in these scenarios. For this first example, for number 9, everything's getting multiplied by 5. And for example 4, everything here is getting multiplied by 3. All right. So very quickly, I do want to take a look at questions 13 and 14. If you want to stick around for some extra help, I'll be doing 11 and 12 as well. So 11 and 12 I'm going to do as additional support questions, but 13 and 14 please stick around for. All right. So again, we have to rely on that formula that I had written on the top of the page, which was a sub n equals a sub 1 times r to the n minus 1. So that's the formula we're going to be using for all of these questions. Okay, so for question 13, we know a sub 1 is equal to 400. We know n is equal to 5 because we're looking for the 5th term. And now we need to figure out, what is r? Well, remember, you guys have to use the formula I'm telling you to use. R is any term divided by the previous term. Well, if I take any term, so let's take this, I don't know, negative 200, and I'm going to divide it by its previous term. So its previous term would be the 400. Negative 200 over 400, that's equal to negative 1/2. So that's really important. My r value is negative 1/2. So I need to plug in for that here. I'll have a sub 5, using my formula, a sub 5, because we know n is 5, is equal to the first term, which is 400, times the common ratio of negative 1/2 raised to the n, which is 5, minus 1. And when you guys type that into the calculator, we should end up getting 25. This goes straight in the calc, guys. So your answer here is a sub 5 is equal to 25. All right, lastly, I'll do question 14 for you all, and then you'll have everything you need to get started on your homework. All right, so let's take a look at question 14. So now we have here, write out our first term. We need to know what n is, and we need to know what r is. Remembering that r is any term divided by the previous term. So a sub 1 is our first term. So our first term in the situation is 81. N, it's asking us to find a sub 5, so n is 5. And r, we take any term, so pick any term you want. So let's say we'll go with 54. And we're going to divide it by its previous term of 81. So we're going to take 54 and divide it by its previous term of 81. When I put that into my calculator, I end up getting 2/3 because we're going to math frac it. We want the fraction. So that means everything here is getting multiplied by 2/3. Okay? So let's fill into our formula. We're going to follow this formula again. So I have a sub 5, where n is 5, is equal to the first term of 81 times the common ratio of 2/3 raised to the n, so 5 minus 1. And again, guys, this purely goes into the calculator, okay? So when you type this into the calculator, you should end up getting 16. All right, so I hope you guys found this video helpful. Like I said, if you want to stick around for just a few more practice problems here, I'll do 11 and 12 for you. All right, but otherwise, you're all good to go. Hope this video was helpful. All right, so for those of you staying tuned here, so let's take a look at questions 11 and 12. So let me erase here what I've got to make some space. We're looking at 11 and 12. And we're going to be referring to this formula up here on top. So let me clean that up since I made a mess of it. We're going to be using this formula. That's for our geometric sequence. All right, so first and foremost, for question 11, again, we need to identify what our first term is, which is 4. We know that n is equal to 10 because we're finding a sub 10. And our common ratio is, well, let's take any term. So I'll take 16 and divide it by its previous term of negative 8. 16 divided by negative 8 is negative 2. So I know r is equal to negative 2. And we're just plugging into this formula. So I have a sub 10 equals our first term of 4 times the common ratio of negative 2 raised to n minus 1. And when you put that in the calculator, guys, we end up getting negative 2048. All right, again, this is a geometric sequence because I have a common ratio. All right, and very quickly, let's take a look at question number 12. So for question 12, again, we have to identify our first term, our n value, and our common ratio. Again, that common ratio comes from taking any term and dividing it by the previous term. So our first term here is 5, and our n value here is 9 because we want the 9th term. And to get that common ratio, again, we're taking any term, dividing it by the previous term. So maybe I'll take any term. Let's take 15, and I'll divide it by its previous term of 5. 15 divided by 5 is 3, so we know that r is 3. That's our common ratio. So let's just plug in. We'll have a sub 9, because n is 9, times, or equals to, the initial value of 5 times the common ratio of 3 raised to n minus 1, which is 9 minus 1. And just put this in the calculator, and we end up getting a sub 9 is 32,805. Alright, so I hope you guys found this video helpful. This is where we're going to conclude for today. There will be one more lesson followed up on geometric sequences. Alright, enjoy the rest of your week.